So, have you ever really thought about what it takes to run an entire mine with self-driving trucks and autonomous drills? I mean, we're not just talking about a couple of robots here. We're talking about a massive, coordinated industrial brain. Okay, let's dive into the architecture behind one of the world's most advanced autonomous operations.
And this, right here, is the core challenge. How do you build a fortress for data that moves? See, when your most important assets are gigantic, moving machines, you can't just use a standard IT setup from an office building. You need something totally different. A digital fortress that's not just secure, but also lightning fast and ultra reliable, right there in the middle of all the action.
To solve this puzzle, the designers looked somewhere you might not expect. They looked to the skies. Yup, to the aviation industry. It turns out that the way a modern airliner is designed gives us the perfect blueprint for running an autonomous mine. Now this is where it gets really clever. It's a two-brain approach. Think about it. In an airplane, the cockpit systems that control the flight are completely, totally separate from the cabin systems, like the Wi-Fi and movies for passengers. You'd never want your Netflix stream to have any chance of interfering with the landing gear, right? Well, this mine's brain works the exact same way. Level 3 is the cockpit. It handles only the critical, real-time operations of the vehicles. And Level 4 is like the cabin. It handles all the data analysis and reporting. That separation is absolutely key to keeping everything safe and stable. Okay, so you've got this cool two-brain idea, but how do you actually build it in a way that you can trust it completely? Well, it all rests on three pillars, three non-negotiable principles that are the absolute foundation for this whole thing. The first pillar is all about speed, low latency control. It just means the system's brain has to be physically close to the machines it's controlling. I mean, when a huge autonomous truck needs to make a split-second decision, you can't have that signal traveling hundreds of miles to some data center and back. The decision has to be instant, right there, right then. Second, the system can never, ever go down. That's what we call high availability. And how do they do it? They created a complete digital twin of the entire operation. There are actually two separate data centers on site, each one a perfect mirror image of the other. So if any piece of hardware fails in one, storage, networking, you name it, the other one just takes over instantly. There is literally no single point of failure. And the third pillar is all about freedom. The whole system is designed to be vendor agnostic. In simple terms, that means it can work with equipment and software from any company today or in the future. It's a true plug-and-play approach. This is so important because it means they're not locked into one supplier, and they can always use the best new tech that comes along. Now, these three pillars, they aren't just for one project. Not at all. Together, they form a blueprint, a standardized model that was designed from the very beginning to be copied and rolled out quickly at future industrial sites. And this really shows you the long-term vision. This is not a one-off custom-built system. The entire architecture is a template. The ultimate goal? To be able to deploy this incredibly complex digital brain at a brand new site in a matter of hours. Not months or years. Hours. That's a real game changer. Let's go back to our airliner analogy for a second. There is one golden rule for how data moves. It only flows in one direction. Level 3, the cockpit, is sacred ground. It is dedicated only to controlling the machines, with zero distractions. Level 4, which you can think of as the ground crew running reports, can receive data from the cockpit, but, and this is critical, it can never send information back or interfere. This setup guarantees that some complex data analysis will never, ever risk disrupting a moving vehicle. So, with everything that's at stake, you can bet that securing this digital cockpit is the absolute highest priority. The security here is intense. It's multi-layered and incredibly strict. The whole point is to create an almost impenetrable fortress around the mine's operations. This quote really gets to the heart of the whole security philosophy. It's all about resilience. The operational network, that cockpit, is built to keep running perfectly even if you completely cut its connection to the corporate network and the internet. It becomes its own self-sufficient digital island. So here's how they pull off that lockdown. First, there's a hard wall separating the business IT networks from the operational or OT networks that run the machines. Second, no vendor gets permanent access, ever. If they need to do maintenance, they get temporary access through a secure gateway, and every single connection requires multi-factor authentication. And this is really crucial. The user directory for the mine is completely independent from the main corporate network. That ensures a problem on the business side can't compromise the operational side. So why? Why go to all this trouble, this incredibly meticulous design, the two brains, the three pillars, the security fortress? It all serves one single ultimate strategic goal.
And that goal can be summed up in one powerful number: 100%.
This architecture guarantees 100% data sovereignty. From the very first design decision, the entire system was built to make sure that every single piece of operational data, every truck movement, every sensor reading, physically stays inside the country's borders, under its own laws. It's nothing short of a declaration of digital independence for a critical national industry. And this brings us to the final and most important question. This project gives us one powerful answer, but it's a question that every country is going to have to face. In a world that's becoming more and more automated, controlling the data means controlling the operation. So who do you trust with the keys to your most vital industries?